You're listening to Raincoast Radio.
Welcome to More Than a Fish, Season 2 of Raincoast Radio. I'm Auston Chhor, a salmon habitat biologist at Raincoast and your host for this series of conversations about the connections between salmon, people, and place. My guest today is Arielle Koenig. Arielle is a master's student in the Pacific Salmon Ecology Conservation Lab at UBC, where her research focuses on floodplain habitats, fish passage, and invasive species. Before starting her grad studies, Arielle worked as a field biologist at Pearson Ecological, working in the Lower Fraser, where we ended up meeting, having a really great field week. Welcome to the show, Arielle.
Yeah, thanks. I'm excited to be here.
We start every episode with a question about home waters because this podcast is more than a fish. It's all about salmon, and salmon are uniquely tied to their home waters where they return. We all know this. And we just want to learn more about everybody's home waters. What are they like? Where they come from? And what kind of connects them to where they come from? So yeah, where are your home waters? What are they like?
Yeah, so I grew up on the Bulkley River, located in Smithers, BC, on the traditional territory of the Wet'suwet'en people, First Nation, and I grew up fishing. It's a smaller part of the Skeena watershed, and it's beautiful and known for its large wild steelhead populations and just abundance of wild salmon up there.
What would you say is the best part about the Bulkley?
I mean, I'm biased because I grew
Yeah,
up
I want
there,
to hear
but
it.
the fishing, yeah, the fishing, it's just so gorgeous. And unlike, say, the Vetter, when you go on the river, there's a lot less people. It's actually reminds me quite a bit about the Upper Pit, like where we met working. It's so calm. Obviously, the Upper Pit's a little more secluded, but yeah, just how pristine and gorgeous it is. Obviously, it has its challenges as well with climate change and everything, but yeah, it's a beautiful water system.
And what made you make the move down from up there all the way down here to where we are now? And you're also in Vancouver right now?
Yeah, I'm also in Vancouver, but decided to do an undergrad at UBC, get a Bachelor of Science in Natural Resources Conservation. And yeah, that was highly driven by growing up on the Bulkley River and fishing with my dad growing up. It was such a big part of my childhood and kind of pushed me to find a career. I wasn't sure what careers were out there when it came to fish, but all I knew is that ever since I was younger, I wanted to work with fish. So I'm very happy to be where I'm at today and so excited to share all I've learned with everybody else.
So you did an undergrad. What was the decision-making process to make the jump to grad school right after?
Yeah, it was funny. In my undergrad, in the program that I did, we have a field school. It's a semester long, September to December, and you go across three different types of ecosystems, one being the alpine, then we went to the grasslands and the Okanagan, and the last one was the aquatic field school, which I was already so excited for, knowing where I wanted to take my career after graduating with this degree. And yeah, while I was there, I got to chatting with a bunch of the TAs in the lab that I'm currently in now. And I never thought of myself as going to post-secondary period because neither of my parents did so. So I was the first in my family to. So grad school was very intimidating and just wasn't even a thought for me. And yeah, after chatting with a bunch of the TAs and members of the lab, they kind of shared their stories of how they got there. And I was realizing that everyone had their own story on how they went about grad school. Like some people went right away, some people took a few years off and established a career first and then went back. And it kind of made it less intimidating to me and made me realize that I can basically do whatever I want to do. Yeah, so yeah, I got that job with Mike at Pearson Ecological and had an amazing time and kept in contact with Scott Hinch at UBC and yeah, just went for it.
So you said you grew up doing a lot of fishing and spending a lot of time on the river. Have you found that your relationship to water and the environment has taken a new light now that you're in a more of academic realm, or do you see some parallels between what you used to do as a kid in the river and what you're doing right now?
Oh, totally. I think it's also funny because my journey and relationship with salmon and fish has kind of shifted as time has gone on because I was also vegetarian for a while. So that kind of threw a wrench into things because, yeah, I loved fishing with my family, but then all of a sudden I'm like, well, I don't eat them. And then so same sort of thing going into school. I'm like post-secondary, I'm learning so much about fish and how they live and how fishing especially can affect their survival. And that's some research that's being conducted in our lab as well, is looking at the effects of catch and release fishing on fish survival. And so it's really interesting, but it's also very cool because I can take all of that I've learned and all the research side of things and apply that to my practice and how I interact with fish and, the basics like keeping the fish wet and keeping them in the water, not exposing them to the air, minimizing handling when possible. And so you can still have that hands-on relationship with fish, but also respecting them and making sure that they're able to thrive. And so we have healthy populations moving forward.
This is going to be great because I actually did my thesis on the same field of catch and release. We're going to have a lot to talk about in a bit. But first, I wanted to ask you kind of like the $1 million grad school question, which is like, what is your thesis on? And I want you to describe it not like I was another grad student in your lab, but as if like I'm your mom or your dad.
Totally. Yeah. So I am studying fish growth and survival, specifically juvenile coho, overwintering growth and survival in floodplain habitats situated near different types of floodgate structures. And with that, we look at the habitat quality. So like water quality aspects such as temperature and conductivity of the water and levels of dissolved oxygen, because fish need oxygen just as we humans do. And yeah, so juvenile coho spend 1 to 2 years in freshwater before they migrate out to the ocean to live the remaining of their adult life before returning to freshwater systems. So in that 1 to 2 year span, that's kind of when I'm looking at the fish survival and growth and seeing how they use those floodplain habitats to grow and survive before their big journey to the ocean.
Could you tell me where geographically this work's happening?
Yeah, so we're working on the Coquitlam First Nation territory in Coquitlam at Lettum Regional Park, formerly known as Colony Farms. So it's just off of the Fraser River, located on the Coquitlam River that like is right beside the Fraser River, feeds right into it.
Could you walk me through? I'm assuming you have a lot of field work associated with your work. Could you walk me through a typical day of what it looks like?
Yeah, so it does depend on kind of the time of year. So I would say at the beginning of the year, we start out with tagging our fish. So to assess their survival, we put little pit tags inside the abdominal cavities of the fish. A pit tag is our passive integrated transponder tag. It's about the size of a grain of rice. And so in early November, we cut open the stomachs of these fish and insert this little tag. Yeah, it's minimally invasive. It sounds really scary because they are so small, but surprisingly, we've only had one mortality last year
Wow.
out of the like 3,000 or so fish that we've tagged.
Are you doing this by hand?
Yeah, all by hand, and that was actually I'm not gonna take credit for that. That was I was training somebody on how to do it, and so that's some pretty good numbers in that sense. But yeah, so we take the fish at a local hatchery where the fish are retrieved from on the Coquitlam River, and then we hold them for about a week after they've been tagged just to make sure that they are healed up fine and well before we release them into the system. And when we're releasing them, we are releasing them on the upstream of these three different types of floodgates. So we have three study sites, and yeah, we release them upstream. And then we basically let them hang out throughout the winter. And then come the springtime, we go out, and that's when we're trying to recapture all of these marked fish to assess their growth. So going back, when we're at the hatchery and tagging these fish, we also process the fish to get lengths, like fork lengths and weights. And then we scan each fish for their pit tag to get their individual code. And then that way we can be able to identify each individual fish and their growth and survival.
How are you recapturing these fish?
Yeah, so we recapture these fish using minnow traps. So we set minnow traps for about 24 hours in the water upstream of these floodgates. And then we just pull the traps, see what's in there, get an overall estimate of all the other fish species that are in the area. And then we also have done beach seining in some sites where we're able to. So we use this seine net, which is basically a big net with a floating line and a lead line on the bottom. And there's a big purse pocket kind of in the middle of the net. So we deploy the net into the water and the lead line sinks to the bottom. And we either go out on a canoe or just walk in if the water's shallow enough and deploy the remaining of the net. And the floating line kind of lets you see where the outline of the net is. And then you go out, do like a big half circle around the area that you want to sample, and then you let it sit for a few minutes. And then on shore, we have about 4 people, one on each side of the net, and one person for the float line, one person for the lead line, and then we pull the net in at the same time. So the net lead line drags along the bottom of the site, and then the float line just stays floating, and then it funnels all of the fish into that pocket at the back. And then we're able to collect the fish and see what we captured.
Yeah, I find it kind of amazing that, I mean, when I imagine releasing a little juvenile into the water, I feel like I'm never going to see it again. And like, do you have a high recapture rate? And what does that tell you about how much these fish are moving in the winter?
Oh, totally. Yeah. So that's one thing that we've struggled with a bit for sure is the recapturing part. And what's nice about these pit tags that we use is that we have 4 pit antennas set up on each floodgate. So we can see when the fish swim in and out. So we have 2 antennas set up on the upstream side and 2 antennas set up on the downstream side of these floodgates. And as the fish swims through, the tag is charged using like an electromagnetic field of the antennas, and it detects the fish as they swim through. And then because there's 4 antennas, we can see how far, if they've actually made it through the whole floodgate or if they've just kind of poked their head in and like swum back out. And yeah, what's really interesting is that we actually see a lot of movements between the sites using this technology because, yeah, some floodgates are less likely to open and may have poorer water quality on the upstream ends. And so these fish we are finding will actually leave those sites to go seek out a site with better living conditions for the fish.
We're kind of getting at this a little bit, but does this project have a big question? What's the research question?
Yeah, so the impacts of floodgates are highly understudied, especially in the lower mainland here. So I'm actually extending research done by PhD student Zachary Shirker in my lab. And he was kind of looking at fish passage through these structures and seeing how the different types of floodgates, whether it be a top mounted, a side mounted, or just a decommissioned chained open floodgate, how that impacts fish mobility and access into these sites. And so I'm taking it just a step further and saying, okay, say these fish are in these upstream habitats of these sites. How are their living conditions? Are they able to survive and grow to the size that they need to be able to take on the big old mighty Fraser River to go down to the ocean? Yeah, it's just kind of seeing what the impacts of these structures are in these highly developed areas.
I remember seeing, I feel like we should add this in the show notes. I remember seeing one of Zach's talks. No, it was your talk actually at the AFS conference, and you had the animated GIFs of the
Yeah.
floodgates and how they all work. And I thought that was like super cool because I think what people don't realize a lot is how where you're working is tidal, right? Like the river, even though it's freshwater, it's so close to the ocean that it rises up and down. And that's when I'm assuming that's when these fish are moving or fish are responding to the tide.
Yeah, totally. The fish totally move in and out with the tides. And so that's why it's so important that they have access to these upstream habitats because that's a place of refuge for them. So they can escape large predators in the main stem rivers and also, yeah, just escape the flow and reserve their energy storage, especially for fish that are migrating from further up the river. In the Coquitlam, it's nice because it's kind of towards the end of the journey, but say a fish coming from Quesnel, BC, like high up there, it's got a long journey to go. So it's important that they have like an area to find a place of refuge.
Yeah, yeah. Like when you think about how much water is coming down the Fraser and how small some of the salmon are, you really understand that they need to get out of it at some point, right? To rest.
Totally, because yeah, they're also usually out migrating with spring freshet, which is some of the highest flows in the river. It's kind of incredible to see what they are able to do and how they persist and survive.
I have done pit tagging in the past, but with much bigger fish. And we've always used a gun. And then with other tags, we've also like, when you cut open the fish and then you put a tag inside them, you have to stitch them up. These salmon are really tiny. Do you do anything to like, how do you close that little cut?
Yeah, so we actually don't close the cut. We make the incision as small as possible. I've also seen people use the guns on the small fish. I didn't learn that way, so I don't feel super comfortable doing that. But basically, we have like a needle with a syringe sort of mechanism in it, and I just use the needle as a mini scalpel, and I just make a tiny incision and then insert the tag with my fingers, and then I give their bellies like a little rub on the sides, and that seems to be
Huh.
the key to their survival after. Then you check them a week later, like when we go to release them after holding them for a week, and yeah, it's like you can tell they've been cut, but it's healed up quite well.
And are you just studying coho salmon or are there other kinds of salmon as well?
Yeah, we're just tagging coho, but with the recapturing, we obviously capture a lot of other species in the system as well. I'm not necessarily looking at those other species, but yeah, they're around and it's kind of cool because I've had two field seasons now and we've actually noticed a difference in our sampling methods and efforts between the 2 years, and we've caught different species between the 2 years. Yeah, so the first year we didn't get any chum at all in our sites. And then obviously last year there was a huge chum return, which probably also helps. But then with the seining that we did last year for recapturing, we caught so many baby chum in the system, like thousands, which was unexpected because we never got a single one with using just the minnow traps the year before.
Oh, interesting. Yeah, maybe chum just don't like swimming in dark holes and coho do.
Yeah. Yeah, maybe. Yeah, and they're also just so much smaller. Like the chum are on average 35 to 45 millimeters in fork length, whereas the coho that we're capturing at that time are much larger, like 120 millimeters in
So
length.
maybe the chum are just getting in and out of the trap.
Yeah, that too.
So you just said you had your second field season, is that right?
Yeah.
So this is the other $1 million grad school question. When are you hoping to be finished? Like how long does grad school take?
Yeah, so typically they say it takes about 2 to 3 years. I'm hoping to be all finished up by like this time next year, so next fall. I've collected all my data at this point now, and it's just a matter of analyzing and writing it all up and putting it all together.
Yeah, and getting edits back from your supervisor.
Totally. Yeah, it won't be a straight easy shot, but we'll get there.
One of my like least favorite but kind of like funniest things associated with writing the thesis was sending it in to my supervisor and then him editing it and then me coming back and incorporating those edits and then sending it back to him and then he would edit his own edits. He would like forget that he made that comment. He'd be like, "Why did you do that?" And I was like, "Well, because you did. You told me to." And
Yeah.
yeah.
No, I've definitely heard that from other grad students. They say some have even said that they get feedback and then just haven't changed anything and then send it in again and they're like, "Yeah, looks perfect." So
That's so funny. Wow.
yeah.
Yeah, so we're hoping this episode can kind of be a reference for people who are trying to get into grad school and maybe or thinking about it. So I wanted to ask, like, now that you've been in it for a while, have you been surprised by anything or learned anything new about grad school and that you might not have known going in?
Totally. Yeah. So one thing that I was always told when asking other people about their grad school experiences was make sure that you're doing something that you enjoy, that you love, because it can get difficult. And I always thought, like, oh, yeah, like I love fish. This is going to be easy. It's not going to be an issue at all. But yes, surely enough, there's been some challenges along the way, mostly with gear in the field. I think field work in general, it can always go awry. Like it's all over the place. And so, yeah, just making sure that you really enjoy what you're doing, because then you kind of have, when those challenges do come up, it's a little easier to tackle them and continue on and persist and say, yeah, I want to do this because I care about what I'm researching.
Yeah, I think that's one of the biggest challenges about ecology as a field is that you go into it with this plan, like you're a chemist almost, and you have all these like very standard and set methods. And then you get things like weather and tide changes and like other people. And
Atmospheric rivers.
yeah, it's just so unpredictable with fieldwork and it can get challenging. I totally understand. I feel like it almost feels like I was just in grad school, so it feels weird to be asking you about grad school. I don't know the way your lab operates, but do you feel like you have a lot of independence in what questions you ask and kind of how your project works?
Yeah, totally. I started out on this project volunteering on Zachary's work. So I was in undergrad, and how I got into this field of research was through that. Uh, yeah, volunteering with Zach. And I got super interested in this because I've never heard of a floodgate before. We don't have those up in Smithers. So every day I'd go out into the field and help Zach, I would come back home and like read all these scientific journals about floodgates just to kind of understand how they were working. And I was so keen and so excited to just have this opportunity to get out into the field. And so then I started reading the literature and kind of realized, like, oh, there's a lot we don't know about how these structures work and how they impact fish, and especially in this area. So I came up with a bunch of ideas. I went back and forth with Zach a bit and then brought them to Scott, my supervisor now. And yeah, I was like, hey, there's all of these things that we can look at. What do you think? Like, do we have something here? And Scott was like, yeah, totally. It's just a matter of funding now. And yeah, I was actually working in the upper pit when Scott, Zach, Dan from Resilient Waters, and Mike all had a meeting about finding a grad school project for me and like trying to source the funding for it and such. And I wasn't a part of the meeting at all. I just like come back from a field day in the upper pit and they're like, yeah, we found a project for you. I'm like, sweet. And then my first field day actually working on the project, I showed up and it was Zach, Mike, and me. And Zach's like, yeah, Mike, so like what's our plan here? Like, what are we doing? And Mike looks at me and he's like, I don't know, Arielle, what are we doing? And I was like, oh, this is fully up to me right now. Yeah, so it was a little bit of a surprise, but all in the best way. It's really cool to be able to decide where this goes and which route to take it. And it's nice to have so much support from everyone around me as well, providing feedback on what they think will work and what won't. And yeah, it's kind of shifted throughout the years and changed depending on weather and all these other challenges, but we've gotten there in the end.
Yeah, I think for me, the transition between undergrad to grad school, like the biggest flip was that suddenly you're in charge of stuff and you're not being like told where to go and that you have assignments due and you have deadlines. Like you're setting all of your own deadlines and your own projects and your own, like, yeah, your own achievables, right? And you're like, oh my God, it's suddenly a lot of responsibility.
Yeah, yeah. And I think that's why, like, I was pretty lucky in the sense that I had about a year and a half between undergrad and grad school, and where I was working as a junior field biologist with Mike Pearson. And he really coached me on how to be independent in that way and like manage field crews because we often did work with so many nations across the Fraser Valley, and having people who may have never even been out on a canoe before and or have identified fish. And so it was really cool because I got that experience working with so many groups like a diverse group of people and kind of coaching and managing and also explaining how biology and ecology works to these people who don't have a background in science necessarily. And yeah, I think that was huge and so helpful for me in my transition to grad school.
Yeah, so it sounds like you've been pretty good mentor even before grad school. Do you have opportunities to be a mentor right now? Like, do you TA or do you have undergrad thesis students that you've been helping out?
Yeah, so I am a TA for a upper level undergrad course right now. I get the opportunity to kind of bring students out into the field and I take them to my study site and explain my research and explain the processes behind how floodgates work and how they impact salmon and other fish, like invasive fish as well. And yeah, it's really exciting because last year was my first year doing that. And I remember asking the class, like, so has anyone in here touched a fish before, like a live fish? And not a single person had. So yeah, it was really exciting to be able to take this like new generation of students out into the field and get a little bit of hands-on experience and also like be able to interact with fish because that was so huge in my life and my upbringing. So it was really awesome.
It's really cool to hear you talk about the new generation of students when the reason why we're interviewing you is because you are the new generation of students. So it's so cool that you're already like taking on the mentorship role. Yeah, I remember really liking TAing too, but I was TAing like Bio 101. And so it was like really funny to see people who are fresh out of high school and learning things like, oh, here's how to prepare a slide. And like, oh my God, I feel so old, right? Like you kind of feel like you're the same age as them, but then you realize like, no, yeah, you do learn a lot in undergrad and grad school and your development like improves a lot, right?
Oh, totally. Yeah, it was quite shocking. I remember my first time being back on campus after working for a year and a half, because I was in the mindset like, yeah, like that wasn't that long ago that I was one of these students walking around here every day. And then I show up to campus and I see everyone and I was like, I don't know. I
I'm
feel so
old.
much older. Yeah. I can't relate to these students.
Do you have any mentors in your lab?
Yeah, definitely. I would say Zach Sherker is my big mentor with that. He was the first one who kind of took a chance on me and let me come out into the field and help him with his research when I was an undergrad. And ever since then, he's been helping me process data and come up with a plan and just talk in general about grad school and the transition into that. And he's been such a huge help. I think that's so important when going this new direction in going into grad school is having somebody that you can kind of lean on and ask questions to and just have conversations as well.
Yeah, yeah. I feel like what people don't realize is even though you're supervised by a professor, it's not like you can just like poke your professor at any time and he'll just answer any question you have. A lot of that support is provided by those PhD students and postdocs, and yeah, and they end up being like your great friends too, which is like way better than.
Yeah, exactly. No, I feel very lucky in general. My lab is so amazing and so great. Everybody gets along and it's a very collaborative atmosphere. Like we all kind of go out into the field and help each other out with each other's research, which is awesome because then you get to gain all these new skills that you may not have been able to otherwise. And yeah, like I've had the opportunity to go out to Bamfield and help with the catch and release fishing studies, like holding studies. So I was just there for 3 weeks and yeah, just get to go out fishing on the boats. And I've also had the chance to learn how to take blood samples on juvenile and adult salmon and also do acoustic tagging and use sensor fish deployed through pump stations. And yeah, there's so many cool things out there.
So I want to switch gears a bit and talk about one of the biggest challenges I faced in grad school. So I was doing grad school in 2019 and just into early 2020. And one of the biggest challenges I faced was like I felt like I was dirt poor. Like I don't know how if it's changed these days, but one of the biggest stressors of, I feel like, a lot of my fellow grad students was being able to just support myself and also go to school as well. And I guess for anybody listening who's an undergrad right now, like, what would you say to them that they need to sort out financially before they get into grad school?
Yeah, the grad school living wage isn't amazing, that's for sure. And I think the biggest thing is just applying to as many scholarships and bursaries and awards that you can. And even that feels like a privileged thing to say because a lot of those are very competitive and require either experience or volunteerism, which is difficult if you're just trying to live and support yourself because living in the lower mainland here is so expensive as well. But yeah, just doing everything that you can and kind of also taking that time between and working. Like you don't feel like you have to jump straight into grad school right away, especially if you can't afford it. Like you might as well like you have so much time in your life to achieve the things that you want to achieve and there's no timeline for anyone. So take the time, make sure that you're doing something that you're interested in and then that way you can kind of also get that experience in the meantime. So when you go back to apply for these scholarships and awards, that will also help you.
Yeah, I think everyone who I've talked to afterwards who's finished grad school has said the same thing. Like take a gap year, or it's not even a gap year, just like take a year between going from undergrad to grad school. But in the moment, it can feel like really like you're being left behind, right? Like if your friends are doing it, going right into grad school, and you're not, right? Did you also struggle with that?
Totally, yeah. Like I think that was definitely a struggle that I had, but after talking even just with my parents and chatting with them about everything, they said, "You know what, Ariel, like you're doing so amazing as is. Like we're so proud of you and there's no timeline. Like you are so young still. You can go back to grad school in your 40s and you can do that. You know, like there's nothing stopping you and nothing wrong with that. People make career shifts all the time. So it's okay to take the time and make sure that you're stable and able to like actually support this life as well. So
On that topic, is a PhD that's something in your future or that you're thinking of?
yeah, I'm not opposed to it. I actually really enjoy research and academia, and I feel very lucky to have the experiences that I've had, but I'm also ready for a little bit of a break as well, do some traveling.
Yeah.
I feel that's where I feel left behind in that sense, is seeing everyone else travel, and I haven't had that opportunity yet. So I think after this degree, I'm gonna do a little bit of that. Maybe we'll do a PhD, but not in a big rush once again. So
Well, I feel like when I was, I mean, how old are you? Like 23, 24,
25.
25. I feel like when I was your age, like it feels like life is moving so fast and like you're gonna get left behind and all this stuff. And then looking back now, I'm like, oh man, I could have totally taken a year or a year here, a year there to just like try something and not feel like, yeah, we have to keep doing new things and like doing the next thing. Yeah, so that's really cool that you've got that mindset already.
Yeah, no, and I think what helped with that is talking with all the other grad students in my lab that I'm in, because we have such a range of ages there, and a lot of PhD students haven't directly gone from high school to undergrad to grad school. Like some people have taken quite a few years off and did some guiding or just established a career doing other fisheries work for and are just returning now to do their PhDs and masters. And so it was really cool in that sense to see all the different routes that people have gone and see that like, oh yeah, it works out no matter what. As long as you're passionate and interested, like you can make anything happen.
Do you have a vague picture of what your life would look like after school if you do a PhD? Let's say you finish your PhD. Do you have that kind of like target, whatever that is?
Totally, yeah. So I myself am Indigenous from the Wet'suwet'en Nation, and I think working with Mike Pearson was incredible in the sense that I got to work with so many nations in the field of fisheries. and I got to see all the different Guardian programs that are up and running. And I thought that was just so amazing, especially Guardian programs that incorporate like youth and multi-generational, like having people from across all generations working together and learning from each other and really reigniting Indigenous culture and language, but also taking care of the environment and fisheries, lands, waters. And I would love to do something of that vein, like moving forward in my future, especially, like I said, being Indigenous. I think it's so important to have more Indigenous leaders and voices at the forefronts of the climate issues and fisheries issues because salmon are such an integral species to so many nations, especially in the Pacific Northwest. And yeah, I think that's kind of the route I want to go. I want to see the culture and language reignited in so many areas, and it's so amazing to see that that's currently underway as well and alive and thriving, especially in like recent years. I think there's been a huge shift towards strengthening Indigenous sovereignty in that sense.
Yeah, we've had the privilege at Raincoast to work with like so many different Guardians programs from like across BC. I feel like everywhere we go, there's either a new one that has started or there's one that's like really well established. And it's just really cool to see how like organized and like passionate these, and a lot of them are youth. Like I've worked in the Nicola, and one of the lead guardians that we've been working with all summer, he's like 19, he's like 20, and he's like one of their longest running guardians, and he's like mentoring 16-year-olds. And you're like, wow, this is so cool. He's so mature. And yeah, it's really been awesome to see. And one thing I wanted to ask you is, now that you've done all this like academic stuff and you're in university and you've learned all of these, very Western science tips and points about salmon, are there some things that you're still learning from your community and from your parents about salmon that you can't find in the university scenario?
Yeah, so my route is a little interesting in the sense that I am a little bit disconnected from my Indigenous family. So there hasn't been a whole lot that I've learned directly from them per se. But yeah, just my father in general, he grew up like he was a fly tyer for fishing shows found on like the sports
Oh, really?
fishing
That's so
shows.
cool.
Yeah. Yeah, it was funny. I was just talking to somebody in my lab and he brought up a fishing show that he loved watching when he was a kid. And I was like, oh, yeah, my dad tied flies for that fishing show. Like, yeah. And so in that sense, I've learned so much from him. And I think it's also different what you learn in school versus the hands-on, like on the ground work is always going to be a little different. I think in post-secondary, they like to say, oh, it's got to be this way and that way. But when it comes to salmon, it's so complex. There's so many issues that you got to kind of keep in mind because so many different people care about salmon. And so just figuring out how to navigate those complexities of working with the different governments, whether it be First Nations or Canadian, and also just like the recreational side of fishers, or even in my research, in the park that I do my research in, there's a lot of birders that also use the same park and they're worried about this and that. So it's just kind of learning how to navigate with the different groups of people, which I feel like is often overlooked in post-secondary. And it's such a huge part of your day to day when it comes to fisheries work.
Yeah, yeah. Like I think as scientists, salmon biologists are some of the most like exposed to the sociology side of things, right? Like you have to know so much about why people care about salmon. And if you're just a chemist doing something in the lab, you have like almost no connection to like society, right? Or like the broader public. But then as a salmon biologist, you have to have that like paper knowledge, but then you also have to know this like the street smarts almost, or like the river smarts. You need to know the people who are walking by the river and asking you like every day, what are you doing? And you need to know like why people care about certain things, because like I think what's unique about this field is that we're not just studying things because they're cool and because they're like scientifically interesting. We're studying things because people care about them, right? And that like link is why what we've been talking about this whole podcast and with all of our different guests. I guess what I want to ask you is if you could describe the relationship between where you come from, your community, and salmon in one word, what would it be?
Ooh, that's tough. I guess reciprocity. The salmon kind of give back to us and give us a chance to connect with the land and the water and have that hands-on experience with them. They feed us and provide us with a great time outdoors.
Yeah. I think that's like overlooked, right? Like the great time
Yeah.
and the fun.
Yeah.
Yeah.
Yeah, like, honestly, even going out to the river and not catching anything, I'm still so happy because I just get to be out by the water and, like, listening to the water go through the rocks and the trees, and it's just so beautiful and such a great time. And then, yeah, it's amazing because now we have the chance to kinda give back to the salmon also, yeah, by just helping out where we can, and I think that's, like, a big thing when it comes to especially, like, my family when fishing and stuff, like, just making sure that we're taking care of these fish and having proper handling practices and like we go out to the river and if we see fishing line and lures and garbage along the banks, like you pick it up and you pack it out just to give back to that environment as well. I think that's so huge.
I recently, there was this report by PSF, and they release this every year. It's called the State of Salmon Report. And it's basically a temperature test of how bad should I be feeling about the state of salmon this year. And, whenever it comes out, there's always the past 3 years have been like, you should be feeling pretty bad. Like salmon are generally doing bad. And as a fellow young person here, I've talked to a lot of more, I don't know, not senior, but more experienced guests on this show who have been working for the past 30 years, past 40 years, like way longer than we've been even alive. And I've asked them how they've been able to stay so dedicated and hopeful to keep doing their work. And it's been interesting to hear their perspective because, they've been doing it so long. But I would love to hear your perspective as someone who's basically just entered this field relative to everyone else. And, myself included, we've been working for, 4 years, right? Or 3 or 4 years in this field. And I want to know what you think about the future for salmon and how you plan on maybe doing this for the next 40 years.
Yeah, totally. I think what kind of drives me to stay so excited and passionate and do what I can for the fish is just seeing how resilient they are. Because they really do face so many challenges, whether it be climate change or development or rising temperatures, overfishing, fish farms. Like their salmon have so many pressures working against them, but yet they return and they do what they can to get back to their natal streams and spawn. And it's been so incredible to be working out in the field and seeing just how persistent they are. And I think that is like very inspiring. Like we should all kind of be like a salmon in that sense and do what we can despite all the challenges that we face when it comes to managing and conserving them, just pushing forward and doing the best that we can.
If you could picture the perfect utopia state of your home waters of the Bulkley, that we've done it. We've like, let's say in 20 years, we fixed it all and this is a perfect river. What would that be for you?
Yeah, just abundance of not only salmon, but people interacting with salmon as well. Because once again, I think that's such an important aspect to salmon conservation is having that interaction with people, with the fish, and also having more indigenous sovereignty over that land and water conservation and management. Yeah, having the Wet'suwet'en Nation be the kind of managers of the watershed and having kind of first say on all of that because I think we have so much to learn from indigenous like nations because they've been taking care of the waters for millennia. Like they know best. And I think there's a lot of insight to be learned from them. So yeah, I think it would be really cool to have that, and also like the multi-generational aspect, like having people from all backgrounds and all ages interact with these fish and just see how incredible and resilient they are, and maybe it'll inspire some hope in everyone.
Do you hope to go back to the bulk lake to work when you finish?
I would like to, absolutely. I think that would be really awesome, kind of giving back to the environment that helped raise me, I think that would be so amazing. But yeah, kind of keeping an open mind as well. It's at the end of the day, it is a small town in northern BC,
Right.
and I have enjoyed my time
The city
here.
life. Yeah. Okay, last question. You've been touching on this the whole episode is why are salmon more than a fish?
Salmon are more than a fish because they glue all people together. They bring in, once again, so many people care about salmon. And so they just really do bring people together and get people excited. And I've seen it from all ages, and from young children to grad students to people who have been working in the field for decades. So many people care about these fish, and it's really cool. They kind of create a community that care about them and bring people together, and that's just so amazing.
It's kind of like a small town. If you just name drop a salmon scientist or salmon steward somewhere, you'll know their name, right?
Oh, totally. There's always connections somewhere in this world, I've noticed.
Well, thank you. That's our time. Arielle, thanks for coming on the show.
Yeah, thanks for having me. That was great.
I want to acknowledge that this episode was recorded on unceded Musqueam, Squamish, and Tsleil-Waututh lands.
Raincoast Radio is hosted by Auston Chhor and produced by me, Sophia Osborne. This podcast is a production of Raincoast Conservation Foundation, a team of conservationists and scientists empowered by research to protect the lands, waters, and wildlife of coastal British Columbia. Learn more and support our work at raincoast.org.